use of limited range of sin x and cos x. So you already know what's the range of sin x and cos x, right? So what's the range of sin x? It is -1 to 1. Both these -1 and 1 are included in this. The range is same, that is -1 to 1. Both -1 and 1 are included. So how to use these values, like how to use this range concept in the trigonometric equations. For example, you have two equations. One is sin x plus cos x is equal to 2. One is sin y plus cos x is equal to 2. In these two equations, which equation is possible and which is not possible? Think carefully. This equation is possible and this is not possible. Why? Let's see here. Just now we have discussed the maximum value of sin y is 1 because it's the maximum value, and the maximum value for cos x is also 1. Here the answer can be 2 because both x and y are different. The angles are different over here. But when you see here sin x plus cos x, for this kind of expressions, we have already discussed the range. What will be the range be? It will be under root minus a square plus b square. That is 2 plus under root 2. So under root 2 is nothing but 1.4 something. So which is less than 2. So this equation is not possible and we don't have any solution for this equation. But for here, we will have because both the angles or both the values are different. Here, if you observe, both angles are same. So these kind of things you need to remember in mind. Now let's solve few questions to get a better idea on this concept. In this question, it is given if x comma y belongs to the range that is 0 comma 2 pi, then total number of ordered pairs x comma y satisfying the equation sin x into cos y equal to 1. So the given equation is sin x into cos y equal to 1. And we need to find the total number of ordered pairs. For this equation, we have only two cases possible. That is case 1, both sin x and cos y should be equal to 1. Or the case 2 is both sin x and cos y should be equal to -1. Okay, so let's solve. Again, this is the so let's find the general solution for all this. So let's find the general solution for these two cases. Here it's sin x is equal to 1, which is in the form of simple t equation. For this, we can write the general solution x is equal to x is equal to 4n plus 1 into pi by 2, where n belongs to all the integers. And similarly, for this equation, it's again in the form of simple t equation. So we can write the general solution as y is equal to 2n pi, where n belongs to all the integers. Similarly, if you see over here, sin x is -1. Again, you can use the simple t equation, general solution. So for that, x will be 4n minus 1 into pi by 2. And for the cos y equal to minus 1, y will be 2n plus 1 into pi. So here let's find the values of x. So here let's find the values of x and y. To this, if n equal to 0, the value will be pi by 2, which is okay because it lies in the range 0, comma 2 pi. If you keep n equal to 1, it will be 5 pi by 2, which is not correct because it does not lie in this range. So for here, it's only one solution when n equal to 0. Now for this, when n is 0, y will be 0. Okay, it is belong to the 0, comma 2 pi because 0 is included over here. Next, if n equal to 1, again y equal to 2 pi, which is again satisfies. But if you keep n equal to 2, again it exceeds this range. So only two values are possible. For this, if you keep n equal to 0, x will be minus pi by 2, which is not correct. So if you keep n equal to 1, it will be 3 pi by 2. This is correct because it lies in the range. So for here, if n is 0, it will be y equal to pi. So it belongs to this range. But if n is 1 or n is minus 1, it exceeds this range. So if you observe, the ordered pairs we need to calculate, right? So the ordered pairs will be for pi by 2, it will be 0 or pi by 2, comma 2 pi. So from here we got two pairs. From here we'll get only one pair, that is 3 pi by 2, comma pi. So in total we have three ordered pairs for this given equation. In this question, we need to solve the given equation, which means we need to find the general solution of this equation. So the given equation is sine 3x plus cos 2x is equal to minus 2. First, think, do this equation exist? Which means, will there be any solutions for this equation? Yes, because here the angle is 3x. Here it is 2x. So obviously we will have the solution, right? So the only one case which is possible over here is sine 3x should be equal to minus 1 and cos 2x should also be equal to minus 1. So let's find the general solution for that, and cos 2x is equal to minus 1. If you observe, now we are talking about the word and means the intersection of these two values, the common values. Earlier, we used to talk about the word or, which means union values. Okay. Now, from here, it is given as sine 3x is equal to minus 1. So, which is a simple t equation. So, the general solution will be 3x is equal to 4n minus 1 into pi by 2, where n belongs to all the integers. And from here, x will be 4n minus 1 into pi by 6. Similarly, this is also a simple t equation. We can write the general solution as 2x is equal to 2n plus 1 into pi, where x will be 2n plus 1 into pi by 2, where n belongs to all the integers. So, let's start taking the common values because we are talking about the word and. How to take the common values? Substitute the values of n and try to find out the values of x. So from here, we can write the values of x as minus pi by 6. That is when n is 0. If n is 1, it is 3 pi by 6, which is nothing but pi by 2. So if n is 2, 7 pi by 6. If n is 3, 11 pi by 6. Next 15 pi by 6, which is nothing but 5 pi by 2. And this continues. Similarly, for this case, the values of x will be, if n is 0, it is pi by 2. If n is 1, 3 pi by 2. Next 5 pi by 2. Next, so on. Now, see whether it has common values or not. There is pi by 2, pi by 2. Next, we have the 5 pi by 2. Next, what do you think the next common value will be? It will be 9 pi by 2, right? And this also continues. So now we need to match these values of x to the given options. Here start taking the values of n. If n is 0, the values of x will be minus pi by 2, which is not a case over here. So this option is wrong. Next, for the option B, the values of x will be pi by 2 if n is 0. If n is 1, it is pi by 2. If n is 2, it is 9 pi by 2. So option B is the required answer to this question. Next question is, we need to find the general solution of the equation cos x into cos 6x is equal to minus 1. So if you observe, how many cases will this equation have? There will be only two possible cases. That is, if cos x is 1, then cos 6x will be minus 1. Then only the product will be minus 1, right? So the next case is, if cos x is minus 1, then cos 6x will be 1. So these are the two possible cases which this equation satisfies. So we have two possible cases. Case 1 is cos x is equal to minus 1, and we are talking about the word and, which means intersection. Next, cos 6x is equal to 1. Next, case 2, cos x is equal to 1 and cos 6x is minus 1. So again, if you see, these are again the simple t equations, so we can find out the general solution. Here cos x is equal to minus 1, which means x is equal to 2n plus 1 into pi. And here 6x will be 2n pi, and we can write x is equal to 2n pi by 6, which means x is equal to n pi by 3. And here x will be 2n pi, and cos 6x is equal to minus 1. For this, the general solution 6x is nothing but 2n plus 1 into pi, and x can be written as 2n plus 1 into pi by 6. Now we need to find the common values. So in this, substitute the values of n. Then x will be pi. If you substitute n equal to 1, it will be 3 pi, next 5 pi, and so on. The odd multiples of pi. From here, we can write the values of x as, if n is 0, it's 0. Next, pi by 3. Next, sorry, it is pi by 3. Next, 2 pi by 3. Next, 3 pi by 3 is nothing but pi. 4 pi by 3. 5 pi by 3. 6 pi by 3 is nothing but 2 pi. So if you observe, the common solutions, the common values will be pi. Okay. Next, 2 pi is not there. So next value will be 3 pi. Here also we'll get somewhere 3 pi. Okay. So the common values of x are pi, 3 pi, 5 pi. So we can write directly the general solution as this only, that is x is equal to 2n plus 1 times of pi. And this is only for case 1. Now we need to think about case 2. Here what will be the values of x? It's even multiples of pi, that is 0, pi, 4 pi, sorry, 2 pi, 4 pi, 6 pi, all the even multiples of pi. Here, if n is 0, it is pi pi by 6. If n is 1, it's 3 pi by 6. Next 5 pi by 6. Next 7 pi by 6. So, if you observe one thing over here, there are no common values. No common values. So, we need to ignore this case. So, the final solution will be x is equal to 2n plus 1 into pi, which is nothing but the option A.